Assalamualaikum students. Students, in this lecture, we are going to do quantitative electrolysis. The quantitative electrolysis is actually related to the charge concept. Q is equal to I into T, and the relation of the charge to electrons, to moles of electrons, and then to balance equation to the concept of the Faraday. So how we are going to link it? Number one, first thing, look, charge of one electron. One electron is how much? 1.6 into 10 power minus 19 coulomb is one electron. Now, if you have one mole electron, one mole electron is this much number of electron, agree? Right? So, if one electron is this much coulomb, one mole electron, charge of one mole electron, which is how much? 6.02 into 10 power 23 electron. It's equal to how much? You have to multiply it. So 6.02 into 10 power 23 into 1.6 into 10 power minus 90. So it's actually how much? 96500 coulomb. Now, look, this is Avogadro number. This is charge of one electron. This is charge of one mole electron. You know what is Avogadro number? It is represented by L. The charge of one electron, E. And charge of one mole electron is what? 1 Faraday. So what we say that F is equal to LE. What is this F is equal to LE? It's actually 96500 coulomb, which is equal to 6.02 into 10 power 23 into 1.6 into 10 power minus 19 coulomb. Like this is, this thing is equal to, this is equal to what? F is equal to LE. Now, listen. The main point that I want to tell you that is that the charge of one electron. Charge of one electron is what? 1.6 into 10 power minus 19 coulomb, and charge of one mole electron is 96500 coulomb, which is 1 Faraday. Now next, can you calculate the charge passed through a cell? The charge that is passed through a cell. How you can calculate? Q is equal to I into T. Q is equal to I into T. Wait. Let me summarize this. Wait. Make it small. Now, next, what is the next concept right here? Can you calculate the charge that is passed to a cell? Like suppose this is a cell. In this cell, there is this emitter, cathode and anode. Like you are passing current. Suppose 1.5 ampere current is passed for 30 minutes. So if you are passing currents, you are passing actually charge. The charge carrier is either electron or ions. In the external circuit, the charge carrier is electron. In the internal circuit, it is ion. And this is current passing for certain time. So this is actually the charge that is passing. So what is the charge? Charge Q is equal to I into T. Q is equal to what? I into T. Now, the I is what? Current for 30 into 60. So this much charge is passed. So can we calculate the charge that is passed? Yes. So any cell, so it's 1.5, wait a minute. It's 1.5 into 30 into 60. It is 2700 coulomb that is passed through the cell. Can you convert this charge into electron and into moles of electron? Two things, into electrons and into moles of electrons. How you will do it? You can use ratio method, you can direct go for formulae. What is the ratio? For electron, we know that 1.6 into 10 power minus 19 coulomb is 1 electron. So 2700 coulomb is X. So it's actually the electrons are charge divided by charge of 1 electron. You will get number of electron. And moles of electron, we know that 96500 coulomb is actually 1 Faraday. It's 1 mole. It's 1 mole of electrons, 1 Faraday. So if you have 2700 coulombs, this is X, so 2700 divided by 965. So moles of electrons are actually what? Charge divided by what? 96500 coulomb. So if you want to find out, like, look, the first thing. The first thing, Q is equal to I into T is the charge. If you know the charge divided by charge of 1 electron, you get number of electron. Charge divided by charge of 1 mole electron, you get number of moles of electrons. The Faradays. Number of moles, it's actually the number of Faradays. Because we know that 1 mole electron is 1 Faraday. 2 mole electron is equal to 2 Faraday. So it's 96500 coulomb. It is 2 times 96500 coulomb, right? So the last thing that you are going to do before application of all these on the questions. The first thing we did this. The second, how to convert the coulombs, the charge, how to calculate the charge and how to convert the charge into moles of electron and the number of electron. The third thing is in chemistry, it's equation. Electrode equation. Like suppose, simple, the one in which the OH in aqueous solution. We know there are too many questions which you use, which use the OH. If the OH lose electron, 4 OH, 4 electron, 2 water, and 1 oxygen. How you will connect the electrons with oxygen? Is this 1 mole oxygen? Yes. So it is 4 mole electron, simple. If it is 1 mole oxygen, it is 4 mole electron. If it is 4 mole electron, it is 4 Faraday. It is 4 times 96500 coulombs. Yes. Look, it is 4 mole, it is 4 Faraday, it is 4 times this much coulomb. And this is 1 mole oxygen, which is also equal to 16 plus 16, 32 gram. 1 mole of oxygen occupies 24 dm3. Can you take the ratio of Faraday with moles, with mass, with volume? Of course. Electrons with moles, with mass, with volume? Of course. charge, with moles, with mass, with like if you know the balance equation, you can take the ratio of any two things, any, right? But if you know the chemistry, before this, what you did, one electron is this much, one mole electron is this much, which is 1 Faraday. We know that F is equal to what? Le. Huh? We know that how to calculate the charge. We know how to convert the charge into electron and into moles of electron. Like if you know these three things, you can do any question. For example, come to this question. This is dilute sulfuric acid. It is electrolyzed for 50 minutes and a current of this much is passed. A gas is collected at each electrode. Volume of the two gases are measured. Calculate the maximum volume at cathode. So it is dilute sulfuric acid. It is H plus OH. So at cathode, cation, so the cation is H plus. So the question is about the volume of hydrogen. What is the equation for hydrogen? Gain 2 electron making hydrogen gas, and it is Q is equal to I into T, I into 50 into 60. So how much coulombs? Look, 1.2 into 50 into 60. It is how much? 3600 coulombs. I'm going to apply this directly. We know that this is 2 mole, this is 2 Faraday, this is 2 times 96500 coulomb. So this 2 Faraday and this much coulombs, this 2 mole of electron is actually 1 mole of hydrogen, and its volume in cm is what? 1 mole of hydrogen will occupy how much? 24,000 cm cube. So if this much coulombs can produce this much volume, so what about 3600 coulomb? X, simple. So what you are supposed to do, 3600 coulomb into 24,000 divided by what? 2 times 96500 coulomb, your answer. Finish. Next. Look at this question. A current of X ampere is passed. A current of X ampere is passed for this much time. We know the time. Q is equal to I into T. We know the time. We need to calculate this, but we need to know the charge. The first question. Okay, this much hydrogen is collected, produced at cathode. Calculate the number of hydrogen molecules. Now I can do this by two methods. Number one, the usual. Most of the students do what? They find the moles of hydrogen. So moles of hydrogen is how much? 462 divided by 24,000. 462 divided by 24,000 is equal to how much? 0.01925 moles of hydrogen. But the question is molecule. These are moles of hydrogen. 1 mole hydrogen is 6.02 into 10 power 23 molecules. So 0.01925 is X. So it is 6.02 exponential 23, and it is 1.158 into 10 power 22. 1.1588 into 10 power 22. We can do the same question through another method. What is the other method? Look, I think this one is more shorter. We know that every 24,000 centimeter cube hydrogen, every 24,000 centimeter cube hydrogen is 1 mole hydrogen, and if it is 1 mole hydrogen, it is 6.02 into 10 power 23 molecules, of course. So 462 is how much? X. So if I do it, it is 462 into 6.02 into 10 power 23 divided by what? 2400. You know, it's exactly this thing. This divided by 24 into this. So this divided by this, you get this value and into this. So it's exactly the same answer. So you get what? Molecules of hydrogen. Number of electron transferred to produce this much hydrogen molecule. Look, these are molecules of hydrogen. The molecules of hydrogen are made by electron transfer and electrolysis. Yes, how? 2H plus gain 2 electron. They make 1 H2. So for 1 H2, for one molecule, 2 electron. So for 1.1588 into 10 power 22 x times 2, this is how much electrons? 2.3177 into 10 power 22 electrons. So charge, 1 electron is 1.6 times 10 power minus 19 coulomb, 2.3177 into 10 power 22 electron is x coulombs into 1.6 exponential minus 19, and the answer is how much? And the answer is quite different. I hope it's correct. Huh? It is 3708. 3708. My calculator is not very good. This much charge, coulomb. So if I know the coulombs from this charge, I can put this coulomb. I can put this coulomb over there to get what? This is 37 to get the amperes. 3708.32 coulomb is equal to I into time is what? 14 into 60. Minutes into seconds. So what you are supposed to do? Divided by 14 into 60. And my answer is what? 4.4. I hope it's correct. 4.41 amperes. Now let me check 68. 68 is, oh, perfect, 4.4. Right? So your answer is what? 4.4 ampere. I hope you understand this question. The second one is also like this. This one is easy. You'll be able to do. I'm going to find another one which maybe, this is also very easy. Look at this. Calculate the mass of aluminium that is obtained when this much current is passed for this much hours. Aluminium mass obtained, it's very easy. Q is equal to I into T. The current is so large, ampere into 24 hours, 60 into first the hours into 60, 60 into then seconds. So you will get what? Coulombs? How much coulombs? Wait a minute. 300,000. 300,000 into 24 into 60 into 60. It's how much? It's, I think, I told you that my calculator is not very good. Into 10 power 10 coulombs. So if you know the coulombs, what is the equation in which aluminium is obtained in the electrolysis? Al3 plus gain 3 electron, making what? Aluminium. We know that it's 3 Faraday. We know it is what? 3 Faraday. It is 3 times 96500 coulomb produce 27 gram. So 2.592 into 10 power 10 coulombs x grams. So it is into 27 divided by 3 times 96500. It is quite different, such a huge number. I can't say anything that with the decimal. Something like 2417409.326 grams. So can we check 71? What is 71? The 71 is, where is that? Oh yeah, it's correct. My answer is it's kg. It's kg. They've given it's in kg. My answer is what? 2417409. So if I round this up, it is how much? 24200 and 0, I think. And if I divide this by 1000, 0, 0, and 0, what is left? Exactly this. So my answer was in gram, it is in kilogram, it's perfect, right? So, any other question? I hope you understand this thing. Any other question which we can do? This one, I am searching another one. Wait a minute. There is this question about charge particles. Wait a minute. The charges. Yeah, this one. Look. Now, they're saying that what is the charge, like the value of N? The value of N when the chromium is obtained at cathode. A current of this much ampere for this much time and this much chromium is obtained. Right? Like, first, what we can do, Q is equal to what? I into 40 into 60. It's minute. So 1.8 into 40 into 60, you get what? 4320 coulombs. Now, moles of chromium, it's how much? 0.776 divided by, what is the mass of chromium? You know, I'm going to check the mass scheme directly because from mark scheme I'm using it. The chromium is 52. The chromium is 52 with it. 52. So 0.776 divided by 52. It is how much? 0.0149 moles. Look, 4320 coulombs are for 0.0149 moles chromium. For 1 mole chromium, it's how many coulombs? 4320 divided by answer, it is 2894. 84.53 coulombs for this much coulombs. For 1 mole chromium, we have this much coulomb. Now I have to convert the coulombs into electrons or Faradays. Moles of electrons are number of Faradays. So how? We know that 96500 coulomb is 1 Faraday or 1 mole. So 28948.53 coulombs is X. So this divided by 96500, and the answer is 2.99. So 2.99 is what? 3. The answer is what? For 1 mole, for 1 mole chromium, 3 mole. So we got the coulombs, we got the moles, and this much moles, this much coulomb for 1 mole, the number of coulombs divided by 965, you get the Faradays. But if you want to put directly shortcut, you know what is the method? What you are supposed to do? We know this is what? N into 96500 coulombs for for 52 gram, because it is 1 mole, 52 gram. For 52 gram, this much. For 0.776 gram, 4320 coulomb. If you cross multiply, you can get the value of N. How? N into 96500 into 0.776 is equal to 52 into 4320 coulomb, and N is equal to 52 into 4320 divided by 96500 into 0.77, and it is 3. Easy peasy. Okay. Now, the last topic of this is how to find out the Avogadro's constant L. My next lecture is on this thing, right? Now, like, subscribe, and share my channel. Okay, see you in the next class.